Hi there. Today's video objectives for the exceptions in FileIO class are as follows. We will talk about what exceptions are and how they're used in the Java programming language, how they're helpful, and the syntax of them. You can use Java's already predefined strings that tell the user what went wrong, or you can code more descriptive strings as a programmer. FileIO is inputting from a file as opposed to the keyboard and as opposed to information hard-coded in your program, and outputting to a file instead of on your desktop like you've usually done. If you have a huge amount of numbers that you want to add or something like that, it would be great to already have them in a file somewhere and be able to handle them and then spit back information to a file, and you would be able to give that information to somebody else easily. And this we are not doing. And so we will talk about the syntax, just how to do that. How do you grab stuff from a file? Do you have to include any other libraries? Do you have to do anything special? And how do you grab stuff from a file, and how do you put stuff to a file? Here's a hierarchy diagram of exceptions, and Java has a class called throwable, and underneath throwable you can have big mistakes, an error, and the program stops running, or you can have an exception where you either stop the program running and you print a helpful string, or you can handle it and the program can keep on running. It's up to the programmer. We're focusing on exceptions, and there are many different kinds of exceptions. So exception, and you notice the capital E, so it's a class, is the most general category. Underneath exception, there's IO exception, input-output exception, class not found exception, so can't find a class, clone not supported, runtime exceptions. The main ones that we're going to talk about are IO exceptions and runtime exceptions. But then you notice under runtime exception, there's all kinds of different subcategories. Here's our null pointer exception. We've talked about that. Illegal argument is going to be talked about in the movie. And then some of them even have subcategories. I'm going to walk you through the code that is available online in the lecture notes. And this has code commented out that handles both file input, output, and exceptions. So at the top of this, you see that we are going to need the scanner class, and we're going to need that when we have input or output from a file or to a file. But in addition to just the scanner class, we need to import java.io.file. There are many different kinds of exceptions. For this particular example, we are just going to need the IO exception, the input-output exception. And then we're going to ask our output not to go to the monitor, but to go to a file. And so in order to do that, you need to import java.io.filewriter. So let's see what this is. You can see that I have a lot of sections commented out, and each section demos a very specific idea. And so throughout this lecture, I'm just going to be doing one block at a time. So let's look at this very top. There is specific syntax with exceptions, and an exception is something that will stop the program, or you can correct a mistake that you have anticipated in the program and continue. So let's look at this first piece of code. Exceptions are also always strings, like this said, and this particular one is written by the coder. So let's say that we have score, and you just ask a simple Boolean question: is the score less than 0 or greater than 100? Let's say that you are grading some papers and the scores can only be between 0 and 100. Well, then a score of 120 doesn't make sense. So if that happens, you want to throw a new illegal argument exception. That is a particular type of exception object that has already been defined. And what happens is, if the score is in the wrong range, then I would call this throwing on the fly. You throw a new illegal argument exception, and you just print out this descriptive string to the user. So let's run this. And you can see right here, exception in thread main, so that's the method that it's in. What kind of argument is it? It's an illegal argument exception. And here is our string that we print out. So I'll run it again, and I'll change this to 90. This statement will be false, therefore the exception will not occur. And you can see that nothing's over there because nothing too exciting happened. Okay, so we'll leave this as 90 so it doesn't affect any of our other stuff. Let's look at the other code. A try-catch block is something very specific to exceptions, and what you do is you try code that you think will cause a problem, and if it causes a problem, you catch it by catching it with an exception, and you do whatever you think is logical to that particular program. So we have a new string, str, and we have given it the string hello. The syntax for a try-catch block is as follows. You have try, it's a reserved word, and catch is a reserved word. We have open-close curly brace that defines the body of what you are trying, what you are afraid might cause a problem. And then we have an open-close curly brace that contains the body of what you want to do if a problem occurs. So here's how it works. If something up here in the try block goes wrong, the instant it goes wrong, it jumps down to the catch block. And anything that was down here is never visited. Now, if all of this information in the try block doesn't cause any problem, then the catch will never occur. It's kind of like an if-else in that regard. So let's see what I did. So I made a new string and gave it hello. And so I just said system.out.println. I got here. Okay, well, that's not going to cause a problem unless I did a syntax error. And then I have a character called letter, and I want to know what is the character at 1 greater than the length. And we know that the length of hello is 1, 2, 3, 4, 5. So what is going to be returned here is going to be 5. Well, we want the char at 5 plus 1. We want the char at 6. Well, we have index 0, 1, 2, 3, 4. The highest index is 4. So this is past the bounds of the string. And so an exception occurs. How we're going to deal with that exception is we're going to shoot down right from here to the catch block, and on this particular one we have not written our own string, so this is an example of let's let Java decide what's best to put in, and we're going to print it out, and the program will end because there is the exception that was caused. So let's run it. You can see that I got here, prints out as expected, and then here is Java's pre-made exception string. Java.lang.string index out of bounds exception. So this says what kind of exception it is. We are out of the bounds of the string that we are asking about. String index out of range, and it's saying that index 6 does not exist. So string index out of range. 6 does not fall within the index of that particular string. Notice that system.out.println, the last letter of the string is, plus letter does not print out. Okay, well, I think what we really meant to do was say length -1. We want to grab the last letter. So let's run it again and look at the output. I got here, the last letter of the string is O, process completed. Therefore, we had no problem here, we had no problem here, we had no problem here. Therefore, the program ran as expected and the catch block was not visited. And let's look at the next part. As I say in comments up here, the same idea could put in a try-catch block, and the catch could have a more helpful string that you have created. String str2 is new string. Ta-da! We see that ta-da is 1, 2, 3, 4, 5, 6 characters long. So it has a length of 6, but it has index values 0 through 5. So here we have this similar situation. We have a try block and a catch block. And so we still have system.out.println I got here. No big deal, just to make sure that we get into the try block. And then here, char letter is assigned str2 char at str2.length. Okay, so we know that this has a length of 6, but the highest index that we can access is 5. Therefore, like the other example, this should cause a problem. If we keep it like this, this is never going to occur because it's going to see this, throw an exception, go say, how do you want me to handle this exception? Go right down here and print this out. And we can see that in the output. I got here, your code did not execute correctly. Remember that the string values begin with a 0, index values. So a little bit more helpful to the user. The next code section has to do with inputting information from a file. And you might ask, why do these seemingly unrelated topics go together? Well, it's because when you get stuff from a file or put stuff to a file, you have to handle it with a try-catch block. And it has a particular kind of exception that you need to deal with, IO exception. And so let's look at what we have here. I have created a scanner object. Remember that I imported the scanner class above, and I called it inFile. This is a descriptive name that will help us understand that it is coming from a file and its input. In addition, you need to make a file object. So let me go to the top of the code right here. Remember that we have 3 imports from the IO library: a file, an IO exception, and a file writer. The file writer is going to be for the output. And so a file is given your own identifier. Okay, so it's an object, so we have file, an identifier is assigned new file, and then you need to have a file, test.txt, that you have your input in. So what we're doing is we are going to grab stuff from this file, as opposed to a keyboard, as opposed to it being already hard-coded, and we have decided that the name that we're going to grab stuff from is test.txt. Now, importantly, you can see that I have a file called test.txt. So in the same folder, so here it is, there's the folder. In that same folder, I have something called test.txt, and let's open it up. And right now I have I am not at home and a new line 42. We'll close that and let's go back to the program. If the file is not in the folder or it's not correctly named, an exception will be thrown. So if you're trying to grab stuff from a file and the file's not there, then that's a problem. And how Java has to handle it is with a try and a catch block, and the catch has to be an IO exception. So we see up here our scanner object has been declared, but it has not been initialized. So let's initialize it with the file. Previously, when we used the scanner object, we put system.in right here because we wanted input from the keyboard. Now we want it from the file. We've created a new file and we're going to pass it that file. So in file is assigned new scanner file name. We're going to grab the first line and assign it to str2. So we're going to use the scanner method next line, which looks for the new line. You've used that in your last program, and print it out. If there's a problem, we're going to say error trying to read from a file, and then i.getMessage is a way that grabs Java's getMessage is already defined for the IO exception class in Java, and it's just going to say whatever the designers of Java thought was appropriate. So let's run this, see what happens. And if you remember, I am not at home is the first line of that input file. Now let's take the file, and I'm going to move that to the desktop. And now we don't have that file reachable in our program. So let's see what happens now. Here's the output. Error trying to read from the file. And which file? Test.txt. The system cannot find the one specified because it wasn't available to the program. This next section of the code demos grabbing stuff from a file until it's done and then printing out some information from that. We have a new scanner object in file 2. And we have some integers that we're going to need. And what we're going to do is we're going to loop around in a file that's available and print out a bunch of numbers. So let's look at that file. It must be called testnumbers.txt. Okay? And the only kinds of files that we will ever read in from or put out to are a .txt or a .dat. So let's look at that. Let's find testnumbers.txt and see what's in there. Testnumbers.txt looks like this: 2, 4, 6, 8, 10, 12, 14. I purposely put one single space between all of these, and then a new line and a new line, and then it's the end of the file right there. So this white space shouldn't make a difference whether it's a blank space or a new line with respect to getting our numbers. Let's see if that happens. All right, we have our try block, we have our catch block, and we're just going to print out the default message if we have a problem. You can create a scanner object, you can create a file, and you can initialize the file. But if you use it, it needs to be in the try block. So let's look and see the order that I did things here. So we have the try block, we have the scanner object right there, but then it's used right here. In file 2 is assigned new scanner. Here you can just make a new file inside, so the scanner needs an object, either the input, the system.in, or a file as modeled above, but you can make a new file right as you go, and then you do have to tell it where the information is stored, so you do have to give it the string that is the exact identifier for the input file you want to use. You can put a whole bunch of stuff in a try loop. Here is a while, and the scanner class has a method that we haven't talked about, hasNextInt. HasNextInt says If you have another integer, let's keep going. If you are done with all of the integers, then this would be false. So while there's another integer to get, inFile.hasNextInt is true, and it goes into the body of the loop. It has another integer, but it hasn't grabbed it yet. So right now it's grabbing it. So nextInt we have talked about. NextInt, grab the next integer. So basically read digits until you see white space. And where are you getting that? You're getting it from infile2. And sum has been initialized to 0, and so we increment sum every time we go grab another integer. But we also want to say how many integers did we grab. That's what the purpose of the integer count was for. And after we have spun around and grabbed all of the values, we have system.out.println, the average of however many integers there were, numbers, is, and then sum and count are both integers, so we need to be careful about calculating the average. We don't want an average of 0. We cast either one of them to a double, and I choose to cast sum to a double, and then we get our value. We ask once again, what are the numbers in here? So we should see 2, 4, 6, 8, 10, 12, 14, the average of those numbers. 2, 4, 6, 8, 10, 12, 14 is 7 numbers, and the average is 8.0. Now instead of outputting to the screen, let's output to the file. We have a string hello world with 3 exclamation points, and we have a file writer object out. So that's what you need to do for output. When you output to a file, you need to make a file writer object. So like we did before for file input, we put the bulk of the rest of the stuff, if it causes a problem, in the try block. Out is assigned new file writer output test.text. What we're going to do with this particular piece is ask for this string right here to be printed out to a file. And a file writer object takes either 1 or 2 parameters. The first parameter is the identifier for the file that we're going to output to. You saw in the reading that you could have nothing at all here, or you could have a Boolean, and let's put it first to false. Oops, let's put it first to false. And what this means is if the Boolean is false, it will erase, if there was already stuff in there, it will erase it and output it fresh each time. And I'll show you that if we change it to true, what it does is it appends the data. The write method takes 3 parameters: a string, the index of the first place of the string that you want to write, and then how many characters you want to write. And so the easiest way to do that is just to say, how long was my string? If you want to write the whole string, you start at the beginning index and you say, I want to write however many characters there are, the length of it, that many characters. And notice that the only thing you can actually write out to a file is a string. So if we have a string like we do right up here, well then that's fine. But if you don't have a string, say you have numeric values that you want to print out, you need to make them into a string. And we'll talk more about that in class. If you want to save your file, you have to close the output file. Out is a file writer object. If you do not close it, if I were to comment this out, it would write to it just fine, but then it would not be saved when the next code was encountered. So you always want to remember to do that, and the right place to do that is when you're done with it and inside that try block, because you're fiddling around with files. So let's see what that looks like. I bring up my output test. Here it is, hello world. And there's only one of them. So how about I make this true, And what's going to happen is every time I run it, it's going to append onto that output. So another hello world will print out each time that I run it. So let's print it out, I don't know, 2 more times. And you can see that we ran it a total of 3 times. Hello world, hello world, hello world prints every time. Let's experiment, and I wonder what would happen if we didn't save it. Let's comment this out and run it. Will there be 3? Will there be 4? Will there be none? Let's see. There's the 3 that are already there, and that kind of makes sense, but not the 4th. We ran it a 4th time, but the 4th doesn't show because we didn't save that 4th output. It was printed out to it, but then it didn't save it. And it was appended and then erased because this parameter is true. Now let's do one more thing. Let's open up that folder, and I'm going to take output test and I'm going to move it out there, and so it doesn't exist right here. And let's run it, and I'll show you that the output does not show an error. No error shown right here. And let's open up the folder and look, and it does exist. Oops, and I forgot to save it. Okay, let me uncomment that out. Let's run it again. Okay, but let's go back to what I just did. I had this commented out, so it wasn't saved, but I also had taken the file out of there. So it shouldn't exist at all, but it does right there. Our empty file exists right there. And we'll run it one more time just to fill it up. But here's the situation. For an input file, let's scroll up a little bit. For an input file, you're grabbing stuff from the input file. It has to be there. Not true for an output file. For an output file, it says, oh, if it's there, that's fine, well, and let's go right to it and output to it. But if it's not there, let's make one. Oh, I guess you forgot to make one. Let's output to it, and we'll create it and use it. Notice that there is no hello world with 3 parentheses here. That's because in our code, we don't have a system.out.println here. We just have a file writer object. So that's kind of weird to get used to at first. So you are used to looking in your output window and there's nothing there and you think it doesn't work right, but what happens is you have to open the file. Okay, and let's talk about the longest one here. So we have a character and we have a string, and it's an empty string, and we have another scanner object in file 3, so hopefully that's going to be an input file. We have a file writer, so it's not a scanner object, it's a file writer, and that's going to be our output file. Everything's done in the try block, bunch of stuff, and then here's a catch. We're just going to let Java handle it on its own, and let's see what we are going to do. In file 3 is instantiated a new scanner object, a new file, and it's called dentist.txt. That's where we want to get the stuff. That's our input. Our output is going to be dentistout.txt. So whether it's there or not already, it will be in the same folder, be created, or either use the one that you made in the same folder. So we have our while loop, and the Boolean test in the while loop looks similar but different to what we used in the very top example on these in this file. Has next, as opposed to has next int, says, is there anything else left in the file at all? And very specifically, the most general thing that it looks for is a string. So while it still has some stuff in it, and we're not looking for a number, so we just say has next. While it has next, we grab the next word, the next string until there's white space. Remember, next grabs a single string and stops if it's one blank space, a tab, or a new line character. It's all considered white space. It grabs a string from the file and assigns it to S. And then this prints that out to the monitor so we can make sure that we are printing the right thing. Okay, so I'm kind of doing a double output here. System.out.println is going to print it out our old-fashioned way to the monitor, but we want to output it also to the output file. That's what we really want to do. What we want to do is we want to wrap to a new line with every single word. And we have talked about /n. We've talked about that a lot. But a better way, especially when you are printing out to text files, is to do /r/n. So technically that's two escape sequence characters. /r is a return to the next line. And then this just said, whoops. And then the /n does what you've always thought it did. A /n behaves itself just fine when it's writing to the monitor. But a /n gives a funky little box character if you only have /n when you're writing out to a text file. And I'll show that after I'm done demoing the rest. And then after we're done, we close it. So let's look at the input. So here is dentist text in our folder, and I opened it up and it says, this is my dentist file, yippee-hi-yay. All right, let's run it and see what our output looks like. So the output is, this is my dentist file, yippee-hi-yay. That's what we really wanted to do. If we want to check to see if that would be the output for our monitor, right there it is. Okay, let me show you what it would look like. So here's what it looks like, nice line wraps. But if we didn't have this /r, let me show you what it would look like. Okay, here in the output window, this is fine because /n works just fine for that. But if we open our output file, okay, well, it didn't even have those funky little squares. Anyway, you have to have /r and /n in order for it to look nice in the output text file. Here's some general information for the syntax of a try-catch block pairing. Here's a try-catch block pairing as I modeled in the movie, and it just has commenting about explaining what we've already talked about. But what I wanted to really focus on in this particular diagram is this down here, example of two catch blocks. And let's say that we have, this is a class called toErrors, right? And we have a main method. This is just an all-in-one program. And what this is going to prepare for is throw arithmetic exception or index out of bound exception. So a programmer has to anticipate one or the other. But the thing that's different about this is that it has a try block and then it has two catch blocks afterwards. You see that the first one catches an arithmetic exception and prints out whatever string it wants to, and then the second one catches an index out of bounds exception error. Here's the way that that works. If you have a problem in the try block, if it is an arithmetic exception, it would go to here, or if it is an index out of bound exception, it would go here. And we haven't talked about this notation, arrays, yet, so don't worry about exactly what this is. I just wanted to present the idea that one try block can have two catch blocks. Actually, one try block has to have a minimum of one catch block, and you would have multiple catch blocks if you anticipate different kinds of errors that you would want to handle differently. Okay, that's all I have for you today. Play with the code that's posted online and download those files and play with things that might cause problems, change the strings in the exceptions, and see what else you can figure it out. I don't have any music for you today, sorry.